All right, we had a little glitch today. So for some of you, you're hearing me do this twice. Please forgive me. I forgot to start the recording. So let's get started, and we'll get started with the important question in this COVID time of why don't ants get sick? And in the main class, we actually had a correct answer because of the antibodies, the little antibodies. So that is actually the answer. Let's see, starting screen, ants get sick because of they have little antibodies. So that's kind of my my foray, my bad joke foray of the day, and it comes from this nice little this nice little image we had. Why don't ants get sick? Because they have little antibodies. So that said, we've got a lot to talk about today before we get started on the lab. Most important probably to most of you is the concept of our grades on the quiz. Grades were not bad. The average of the was a 77.29 and the median was an 80, so that's actually not a bad grade. We're not completely graded yet, or actually we are completely graded yet, except that it didn't get done until late last night, and I haven't had a chance. There were a couple of things that the TA and the mentors wanted me to look over, but they did a really good job of, in general, of grading everything. I'll take a look at a few things, and we'll be releasing grades as soon as possible after that, certainly before Monday. Now, I was working very hard earlier, or I was pushing my staff, the instructional staff, your mentors and TAs, pretty hard earlier to get them to get grading done, because when I started the semester, the drop class course drop deadline was on 3/12. Sometime over the semester that has been moved to 3/19, or maybe I just had bad information. So I will make sure you have this in plenty of time to make any decisions. I'm not encouraging any of you to drop. In general, I think this is this is a 10% on your grade, so I don't think it's going to have a big impact on anybody's grade in general anyway. But you will have this along with 5 labs and your analysis paper to make a decision on whether you want to drop or not by the 19th. So we will hit that deadline. You'll have it early next week. We have been encouraged by the powers that be. Everybody understands the stress you guys have been under. It's been a long slog, and not having a spring break, that's always been a rejuvenative time for everybody. So we are being encouraged to give you a pseudo spring break. We're not coordinating this. I don't know that every professor is going to do it, but we've been asked if it's possible within our schedules to give you the ability to have a little time off from one course at a time, I guess is the way to phrase it. So it works out that there's a conference that I would normally attend, and I would normally get a guest lecturer that occurs, next week. So I apologize that this comes during your COVID quarantine. I kind of wanted to give you the opportunity to get out and get some clean air and relax a little bit. But because of that timing, because of this is exactly in the middle of the semester, I think we're going to run it next week. So what does that mean? Well, it means that next week I'm not going to be lecturing, and we're not going to be holding a lab. I will be holding class. It's optional. You don't need to show up. But the concept is that it will give you time to work on your projects and to work in your groups. I'll hang out in Nook. We will use the student rooms. You guys can gather in your project teams, or if you want, you can gather in multiple project teams and just work on your projects. Or if you want, you can work at home or do whatever you want. I'm not taking attendance. It's part of getting you started, part of getting you set up in your projects. I want to do this for a couple of reasons. One is just that it's a fast semester. We're about halfway through, and I want you guys to start being able to produce on your projects, and that means you need time to work. this will be a time to work. It's also a time when I'll hang out in Nook and I can answer any questions that you have about getting started or creating a Git repository or licensing or any questions of that sort as you get started in your projects and as you push things forward. So we'll run this kind of like we'll run both days kind of like a lab or maybe a study session. You guys drop in, you work together to the extent you want, and you can ask questions of myself or any mentors who happen to be around. And other than that, you don't have to worry about tests, you don't have to worry about new material, etc. If we look at the schedule, that does mean we have to change the schedule a little bit. So, this is kind of where I'm sitting. Right down here, we're doing the lab on scientific computing today. By the way, it's something I forgot to mention in the last one. This lab is not due until next Thursday night. The mentors and the TA have been suggesting that I give you more time to do the labs so that you guys have more time to ask questions of them during office hours. And so perhaps that'll make it easier for you to get things done. So this will actually be due next Thursday. That week is also our pseudo spring break, and the week ends on drop day. So that's the last day to drop. Here's the important thing. One of the reasons I want to give you the opportunity to work on your projects is that next week I want to do project update presentations. And this is just a minute, maybe 2 minutes. I want each group just to tell me what their project is, what they're doing to get started, anything they've accomplished. And just the goal here is not to give you a big grade on your presentation ability. It's to make sure that everybody has a project, everybody's project is well defined, and I know what everybody's project is. So, work on your projects next week. The week after, you're going to just give me an update on your current progress. All right? You can ignore, to some extent, the topics from the 23rd on. There will be some mixture of these topics and maybe with statistic computing in. I'm not exactly sure. I need to, part of what I'm going to be doing next week is rearranging our schedule to kind of flow in with this new flow. The very last thing I want to mention is that the last 3 classes are project presentations. So, we are getting close to the point where you guys need to have some stuff. You need to get started. We need to get things done. And then at the end of the semester, you guys will have to do a more formal presentation that will actually be a significant part of your grade. Okay? I think that covers everything that I did not tape the first time. So I think at this point I'm going to stop the recording and we will splice this together in some kind of coherent whole. Thank you very much. All right, let's move on. Today's lab is on scientific computation, and it's lab 6. And it's not on 3.8. It is, man, how did I miss this? I revised this thing multiple times. Anyway, so it's on Oh, yeah, let me put up the file. Okay, so I put up the lab on scientific computation. You'll see that I haven't fixed this one at all. I will try to get this fixed as well. But just ignore the 7s and make them 6s. Yeah. this is what we're going to do. We're going to use something called networks. It's a network analysis library. There's a little tutorial on it at this link. I'm pretty sure I checked out that link. And you'll also need matplotlib. So make sure that matplotlib works for you. You will have to install, if you're using WSL, you'll have to install Xming or one of the other X11 windowing softwares. I think that was already necessary for something we've done previously. So if you're following along with the lectures, you should be good with that. Just like in the labs, you're going to want to be using Python 3 and pip 3. I left it Python and pip because you really don't know how that's been installed in any specific environment. But I ran through and it seems to be working. If you run through these examples, that will give you a very quick and dirty analysis of these first two bullets. They will show you whether your system's working and whether you have issues with your system or not. So please take the time to go over those. Now, you don't have to read the book. You don't have to read all of Dr. Goldschmidt's master thesis, but they're interesting problems, including this kind of wordplay problem. What the lab is about is it's about the word ladder game. So if you remember, Python-V will tell you the version, or -- version I think works as well. So this particular exercise today is, if you've ever played the game, get from chaos to order in 6 steps. Right. So you take the words, you change one letter of the words, and you keep all the letters, all the rest of the letters in the same order. And by changing one word at a time and going from one valid word to another valid word, you can actually, make a string of, so here's the first 2 bullets, right? So let's click on the word ladder game. So basically, you start at one word, you change one letter at a time, and you make it to another word. And that's what this graph algorithm does. Now, the important thing to recognize is that we actually gave you an implementation. Okay, this actually works for words of length 5. So you don't have to write this. This is open source code. Smart programmers are lazy programmers. So what we want you to do is we want you to start from this code and complete the rest of the exercises. Okay, so once you've installed networks, once you've installed matplotlib, once you get those working, then go through the rest of the exercises. And what they're going to ask you to do is change the algorithm to do different things. We want you to do it for words of length 5, but the built-in test has a sequence of tests it runs. We want you to run it on these word pairs, right? Then we want you to take the base code and make the changes necessary to go from words of length 5 to words of length 4. Okay, and then we want you to go in and we want you to do a little bit of a different word ladder. This time we're going to allow any order. So you change one letter at a time, but the words are not required to keep the rest of the letters in the same position. So this, so you'll see here, like, to get from chaos to order, chaos goes through echoes. So we took the A, we replaced it with an E, but CHEOS is not a word. However, echoes, a reshuffling of chaos, is a word. So, so those are the basic things you're required to do. And then we have an optional one that's kind of fun. This is just basically looking at the graph and finding words that, on the word ladder that come before and after the other, the specific words. So it's kind of fun. I found this to be a very interesting assignment. The reason we're giving you this assignment, there's a number of open source principles that this attacks. The first thing it attacks is it uses open source software, right? All of this stuff is freely available and open, and you can download it. When you're using other people's code, you need to be able to read it. So reading and modifying it are actually oftentimes more difficult than writing something from scratch. And this time, I don't think it is. I think this is a relatively decent algorithm. And then it also, these exercises we give you are taking a base algorithm, the code from Professor Goldschmidt that goes through with Python implementation of the word ladder game, and you're going to actually modify it and make it do what you want to do. And that's it's a very open source thing to do. Take a piece of code, modify it to meet your needs instead of somebody else's. The other part of this is it's going to use this open source networks library. And this networks library is actually a piece of graph analysis code. So this is a fun piece of scientific software, but the whole basis behind it is doing graph analysis, looking for clicks, looking for paths, right? This is looking in particular, this is looking for a shortest path. It encodes the network. It encodes the words ladders. It changes one letter at a time and builds a graph of all letters that are reachable from the current letter by changing, one letter. And then having done that, it analyzes the shortest path between two nodes. So that's kind of an interesting and fun application of graph analysis. Anyway, that's the lab. I don't think it's completely burdensome. Most of your changes will be very local. So if you find yourself making changes very far afield or substantial changes very far afield in this example code, reconsider, take another look at things. It should be relatively local. It should be, there'll be probably an aha moment where you figure out what's going on. Other than that, go off and have fun. I am probably going to go back and talk again to the first couple of slides. You are welcome to turn down the volume, but having started the recording a little late, I want to go back and cover the first amount of material, and you'll find it relatively redundant. You won't find it exact because I don't necessarily have a script that I'm following, as you can probably tell. Any questions? Why is this? Oh. All right, why don't you guys get started? Feel free to join tables, work like we've kind of shown you. Feel free to work amongst yourselves a little bit. You don't have to watch alone. You group up, ask one another questions, and just make sure you turn in your own work in the end. We are looking for your own work. But you can tell that this one is going to be, hopefully you guys will be fairly close in most of the ways you do things, because there is a very easy solution to every one of these questions. All right. If you have any questions, we're going to hang out here for a bit. Like I said, I am going to start over again and do the first part of the discussion. Again, feel free to turn down the volume if you'd like. It will be easier for me than giving the whole thing over after you guys leave today.